Let's see. Hello. I think I'm ready. Do you hear me? Does it seem like everything's okay?
Yeah, we could hear and see you.
Okay, great. Okay. I didn't get a chance to update the website, so there's not an entry for today. Yeah, I was I don't know if you noticed I finished grading programming assignments 1, 2, and 3 for this class. So please go look at your grade. I didn't put any comments with the grades. Um, if it I you know I had if you have questions about your grade, you can just send me an email and I can tell you like what I found in your programming assignment. I don't really have a convenient way to give you back the programming assignments. So I have the notes and whatever about your assignment are on my computer. So if you have a question about your score on a programming assignment, just send me an email and I can tell you like what tests failed or what I found when I was looking at the assignment. Okay, so it's a little bit hard to give feedback for the programming assignments through Brightspace. So you should. Did anybody know? Did everybody see that? Did anybody notice that that it should be there? Your grade should be there for assignments 1, 2, and 3. Did anybody notice them yet?
Yeah.
Okay. Yeah. So if you don't have a grade for assignment 1, 2, or 3, it probably means that I didn't receive one from you. But if you didn't get a grade for assignment 1, 2, and 3, and you're wondering why, send me an email. But I mean, everybody who's submitted one, I think I graded all the ones that were submitted. Okay. So if you have questions about programming assignments 1, 2, and 3, please send me an email or come to office hours. And assignment 4, uh, a lot of people still haven't turned in assignment 4. I haven't graded that yet. And assignment 5 was assignment 5 was due today. So there's no point grading. And assignment 4 was due a little while ago, but not everyone has turned it in. So so 1, 2, and 3 have been graded so far. Okay. Okay, next about assignment 5. Is there any question about assignment 5 that's due? Okay, it's due today. If it's due today, but if you turn it in next, like I said the other day, if you turn it in before a week from today, say, I should be able to grade it. If you turn it in after next Thursday, I may not have time to be able to grade it. Okay, so I may not be able to have time to grade things after Thursday. So at the very latest, things should be turned in by next Thursday, at the very latest. But and I can't guarantee that I'll have time to grade everything. But certainly, I'll try if it's up to up to next Thursday. Does anybody have any question about assignment 5? Any question at all about anything that's come up with the program assignment 5? All the information about it is actually in here. Okay. Anybody have any question about program assignment 5? Anything? Okay. If you have questions about 5, send me email or come to office hours. Yeah, people have sent me emails. I'm working on answering all the emails I've gotten. For the last several days, all my time was spent trying to get the grading done for those 3 assignments. So I haven't answered too many emails in the last couple of days. I've answered a few, but mostly I've been grading. So if you have questions about assignment 5, if you're still working on it, or actually for that matter, all the other assignments, if you're still working on anything and you have questions about them, please send me email and I'll try to answer them as soon as I can. Okay. Okay. So any question about assignment 5, or for that matter, any question about assignment 4 that's still a lot of people haven't finished it yet.
I think I had one about assignment 4.
Uh-huh.
I'm on mobile right now, but there was a question. It was write a function that takes in A lists and B lists, return B lists of B list minus the length of A list. I think it was like the 6th question.
Okay, let's see. The drop, let's see, is it the one that dropped?
No, I think it's down a couple.
Yeah, trim.
Trim list.
Yeah.
Yeah.
Mm-hmm. It takes two lists. It essentially, you use this as a count of how many items to drop from this. Okay, so you don't even look, you don't use these items in any way. And essentially what you do is, as long as there's something in here, you drop something from here. So it'd be it's a kind of simple recursion. If this list is not empty, then you drop something from this list and drop something from that list, and then you recurse. And then if this, so if there's something in this list, then the head of this list gets dropped along with the head of this list, and then you do recursion. Then the head of this list will get dropped, and the head of this, what's left of this, will get dropped. Then you do recursion. Then this one will get dropped, and this one will get dropped. When this one's empty, you return what's left on this one. So when the first list is empty, there's nothing to drop, so you return all of the second list. So you just recurse on the first list. Well, you recurse on both lists. You drop one from here and drop one from here, and just keep doing that until there's nothing left in the first list, and then then you return the next list. So like trim list of the empty list with 1, 2, 3 will give you back 1, 2, 3. So that's what ends the recursion. When this one's empty, that's what's going to stop the recursion. Okay. And on the other hand, if you're asked to trim 1, 2, 3 items from the empty list, there's nothing to do, so you'll return the empty list. So that also stops the recursion. When this list is empty, there's nothing left to trim from it, so you just stop the recursion. So there's two things that stop the recursion, but you have to check them separately. If the first list is empty, there's nothing to trim from the second list, but then you return the second list. If the second list is empty, there's nothing to trim from it, so you return the empty list. Okay, so it's a pretty straightforward one where you just recursing on. If you look at the examples we did in class, here's the recursive function examples. There's one in here that's similar to that. Kind of like pair up, except that you're not, it's kind of like see, pair up recurses on two lists. No, I'm sorry, not pair up, because it doesn't recurse on two lists. Kind of like zip up. Zip up recurses on two lists. Okay, so notice how you're checking whether this list is empty or this list is empty. Now, in this case, you return empty on both of these. So, but it's similar to this idea that you're recursing on this list and you're recursing on this list. What do you do when this one's empty? What do you do when this one's empty? See over here, whoops. As you can see from the examples here, it's not quite here. It didn't matter whether this one's empty or this one's empty, you return the empty list. Here you can see it's different. If this one's empty, you return that one. If this one's empty, you return the empty list. So very much like that. Okay. And then when you've got non-empty lists, basically you just throw away this part. You'll just throw away that part. That's the trim part. So in trim list, you'll just throw this away because it doesn't matter. You're not using them. So you'll just recurse on what's left. Okay? So it's real similar to zip up, It's almost the same as zip up. It's like the only real difference is, what do you return when this one's empty? And what do you do with the two things at the front? Well, you throw them away. You don't use them. In this case, you throw them away. Okay, right? So now most of the homework problems have something similar with these examples in this file here. Yeah, there's not all that many patterns to recursion. So the examples in this file here that we did, the ones we worked through in class, they actually have most of the ideas that you would need. So a lot, the homework assignment, you can usually find something in here that's real similar to the program assignment, and use something that, use a recursion pattern from in here. Like this case, the pattern was recursing on two lists simultaneously. Okay, so trim list looks like zip up. Okay, so trim list looks like zip up, and you can take the code, you can actually take this code here, copy and paste it, and make a few changes to it, like change the name, make a couple changes to it, and you'll have the right answer. Okay, and and that's like a lot of programming. Programming is a lot of times knowing when to use a pattern. Look, a big part of programming is to see how one problem is a pattern similar to a previous problem. So reuse code, but you have to recognize the pattern. Okay, in this case, this one looks like that one. Trim list looks like zip up. Okay, because it's shortening two lists simultaneously. Okay. Okay. Yeah. Any question about that one? Remember, go look at zip up. If you're trying to do this one, go look at zip up and think about how that one works and use it to do this one. Okay. Okay. What about any other questions about homeworks 4 or 5? Okay. Now, other thing is the exam is next week. There's a exam next week. The exam is mostly going to be these kinds of problems. I haven't had time to, because I was doing all the grading. I didn't have time to do this. I'm going to put a few more problems in this review to kind of summarize what the exam would kind of be like. But it's going to be problems from these lists of problems. Okay, so these are the kinds of problems that you need to be able to do. So these are the kinds of problems you've had in the homeworks assignments. Writing simple recursive functions, given a type, understand the type, be able to understand patterns. So be able to understand patterns, understand types, and write recursive functions. That's what it boils down to: patterns, types, and recursive functions. And then also higher order recursive functions, functions that take functions. Okay, so there's also the higher order functions. Okay, so I'll probably tomorrow I'll be able to put some more problems in here, some new problems in here. They're an example of like what might be on the exam, but they will come from these. It'll be problems from these lists here. Okay, and these are the problem. These have been the sample, like we just did this problem here. Thought about this trim list. The whole point of trim list was to recognize that it's very much like one of the recursive functions in here. Okay, so most of these we solved in class. So the solutions to a lot of these problems are on this page here. You have to kind of, right now I didn't link to, this is just the problems. Like right now, this links to the problems. I didn't link yet to the solutions. The solutions are up here on the page. If you Control C, Control F, there's the solutions. See, use the two. Yeah, see, you can find the solutions just by searching the page. Okay, so there's the list, and then here's where we solved a few of them. Here's where we solved a few other ones, and here's where we solved another one. Okay, so you can find the solutions on the page. Okay, okay. So most of these, like here, type declaration problems. I think these were also. Okay, there's some solutions to those. There's some solutions, yeah. See, there's some more of them with their solutions. Okay, so the solutions are on, many of the problems have solutions on the page, and you can just search the page for the files that solve them are on the page, and you can just, Control F and search the page for them and find the solutions of these things here. Okay. And then, like I say, in the next day or two, I'll put a few more problems in this file here, but they're not there yet. Okay. Does anybody have any question about the exam?
You said that the exam would be you just post it and then it'd be due later on in the day.
Yeah, if you, pardon me?
Do you know what the cutoff time would be?
I was thinking around 11 o'clock. That's what the cutoff time was like for the other class. Yeah, say like 11 in the evening. Okay. If you're in the operating systems class, it'll be the same way that the operating system exam was done. Okay. And if you're not in the operating systems class, the exam will be on Brightspace where the homework assignments are. And the exam will be a PDF document that you can download and write either you can download the PDF document and write your answers in the PDF document, then scan it in, or you could copy and paste the problems into a Word document or a Google document and put your answers in the Google Doc also. So yeah, you can either write your answers on a piece of paper and scan it, or you can copy and paste the problems into a Word or a text file. Even you can just copy and paste them into a text file, so you could test your answers in ML. So you can test your answers in ML. You can use ML to test your, that's an important part. It's essentially like an open book take-home exam. So you have ML to use to check your answers with. So that's part of the thing. I'll expect you to use ML to think about how to solve the problems. Okay, so you'll have ML, so you can take the problems and punch them into ML. Okay, it's a test. It's not it's not a collaborative programming assignment. You're supposed to do your own work. Everyone's supposed to do their own work, but you will have ML at home, so you can check your answers on ML. You can use ML to test your code to see if you're getting what looks like it should be the right answer. Okay. So the problems will be in a PDF document. Usually what I do is I put two documents up on the Brightspace, a PDF document of the exam and a text file, because it's really tough sometimes to copy and paste things out of PDF files. They don't always copy and paste very well. So I usually put the PDF version and a text version up on Brightspace, so that the text version makes it real easy to copy and paste. So you could copy and paste, say, directly into ML to try problems out, to experiment. Okay, so the exam will be, you'll download it from the assignment page in Brightspace, which is the same page we use for uploading the assignment. So you'll download it from there, and then you'll upload it back to there. So you'll download it and upload it both from the assignment page. Okay. Right now you download the homeworks from the website. So the exam will be in Brightspace. So right now you download the homeworks from here on the website, but you upload them to Brightspace. For the exam, I just make it so you download and upload it both from Brightspace. You download the exam from Brightspace and upload it back to Brightspace. Okay, so that works better for the exams. Okay. Any other question about the exam right for now? Anything? Okay. Now, I want to show you something about types today. ML, I mentioned the other day that the two things in ML that are really powerful, that have had a lot of influence on programming languages in general, are the pattern matching, and the other thing is algebraic data types. Okay, the pattern matching is made it into Java, and it's becoming part of Java. But the algebraic data types, they've had their influence on Java. I want to show you how they had their influence on Java, but in kind of not as good a way as they could. Okay, now here's the starting point. Okay, this guy here lets you say that a data type is a Boolean or an int. Okay, that's a really weird thing. That has no, well, I shouldn't say it has no analog in Java. It has a weak analog in C and C++ using these things called union types, but they're still not quite the same thing. But what this is essentially you're saying that this variable, this type, is the union. Like in the discrete math class, this is one reason why we make you take discrete math. You learn about set theory. Here's where programming languages are using set theory. These are called, in general theory, they're called union types. So you can look up union types, and you can see there's a Wikipedia page about union types. And that's what we're talking about here. We're talking about ML's ability to have union types, okay? This or says, yeah, that's what the union of two sets is. You're either in the bool set or you're in the int set, okay? But we have to give a name to these two parts. So we say that a bool int is a bool part of Boolean or an int part of int, okay? Then we can define functions that take these, like this function takes in a bool int. Well, actually, I'm sorry, this function is going to return a bool int. And it takes in an int. And if the int is negative, then it's going to return, well, actually, I'm sorry, this function is going to return a pair of things. This function is going to return a bool int. Okay, this function is returning a Boolean and an integer. Okay, see, if x is negative, return a pair. Pairs are ands. These things are ors. So this is returning a Boolean and an int. So if the input number is negative, you say false -1. If the input number is positive, you say true +1. So it's kind of an artificial example, but it's saying you return a bool and an int. Now G takes in an integer. If the integer is negative, then it returns a boolint, but it returns a Boolean for the negative numbers, and it returns an integer for the positive numbers. Okay, so see, it returns a Boolean for the negative numbers and an integer for the positive numbers. So it's returning a Boolean or an integer. It's returning a Boolean or an integer, whereas opposed to this one's returning a Boolean and an integer in both cases. Okay, so this is thought of as, these are called and types, and these are called or types. Okay, and this is called in general algebraic types. The algebraic data types. The algebraic data types come in two flavors: and types and or types. Okay, see, or types. See, there's the or type, and the and type is usually written as tuples. Okay, tuples are the and type. Most of the emphasis in this page is on the or type, because the or type is the really interesting one. And types are in Java and C++, but or types aren't. Okay, you can do this in Java by returning an object that holds a Boolean and an int. You can just define an object in Java to hold a Boolean and an int. It's just, you call the Boolean B and the int X. So Java lets you have ands. You can return two pieces of data bundled together in an object. But Java doesn't have a way to return this or that. It has no way of saying, I'm going to give you a bool sometimes, I'm going to give you an int sometimes. There's no way to have this. So this function can be written in Java. There's no way to write this function in Java. Okay, this is the and, this is the or. Okay, the or is the interesting one. The or was the real invention of languages like ML. The ands had been there all along, but nobody thought of them as ands. But at some point somebody thought that this is really this is Boolean and int. Why not Boolean or int? And they figured out a way to do that. Okay, and then that turns out that that's really powerful. And the example we looked at the other day that kind of hints at what's going on here is when you in Java, this is real simple. We did this example, and I'm going to do this example a bit more elaborately in a minute. When you search a string, okay, you want to know if something is in the string or not. So you need an answer, yes, it's in the string, or no, it's not in the string. Okay, notice that there's an or there. Yes, it's in the string, or no, it's not in the string. Okay, now that really begs an or type answer of an answer that says the or would be yes or no, success or failure. Instead, what Java does, it returns an int in both cases. It returns an integer that's positive in the case of finding this thing, and it returns -1 in the case of not finding it. But the trouble is, -1 is a perfectly valid integer. It doesn't say, the -1 by itself doesn't say that this thing didn't find the integer, the z. So what that means is I can take that answer and plug it back into another search. Okay, so if I see, the idea here is I would look for z in this string, and then wherever I found z in this string, I'd ask, okay, what's at that position in this other string? So I'm kind of matching up letters in two strings. In one string, I search for a z, and then in the other string, I say, okay, what's at the same place? The trouble is, if the z is not in this one will crash. And that's what happens in this one. As you go through here, this one will crash the program. Now, Java had no way of knowing that this was something wrong with this. Okay, there's no way for Java to warn you that there's something wrong here. What's wrong there is I didn't check whether this thing was a success or a failure. If this was a failure, I shouldn't have used the answer. See, this was success or failure. Java doesn't know that. And if I'm not careful in my programming, I don't check for the failure case before using the answer. And this is a big problem. This is where huge amounts of bugs come from. Huge amounts of bugs in Java programs and C++ programs come from doing something that's going to return a success or failure. But instead of using something that really denotes success or failure, they just use something. In this case, they're using an int. Some of the ints mean success and some of the ints mean failure, but they're all ints. So the compiler doesn't know which one was which here. So that means you have to write code to say something like, you should say something like if n not equal to -1, then you can use that. See, you have to make sure you test for the failure case, but the compiler is not going to force that on you. Okay, now this becomes a more serious issue when you're searching a list for something. Okay, so let me show you an example of that. Oh no, that's the same one. Search a list. Oh, where did I put it? Oh, let's see. Oh, I hope I didn't delete it. I just wrote it just this morning. Let's see. Let's see if did I delete it? I may have accidentally deleted the thing I just wrote this morning. No, it's not there. Hmm. I'm looking to see if it's on my desktop. Now I'm trying to remember where. Oh, there it is. Put it in the wrong folder. Okay, search list. Okay, I kind of put it in the wrong folder. Okay, here's a little bit more elaborate example. Same kind of idea. Okay, I want to search. Here I'm searching a string for a substring, or I'm searching this string for this substring. I'm searching a string for a substring. Now I want to search a list. So I create a list of strings. Okay, so I create a list of strings, and then I want to see if the string cats is in that list of strings. Okay, now Java doesn't do this very well. Okay, so first of all, Java does it the same way it does strings. There's an index of method. So on my list, I call index of. Now, if I go to the Java 11 list class, you can see that this is in the list class. Okay, in the list class, there's a index of object that searches the list for that object here. Okay, and notice it returns -1 if it doesn't find it. Okay, but that's this thing index of really is returning an OR. It found it, there's the integer where it was, or it didn't find it. But if it didn't find it, it's returning -1, which is still an integer. But now you're still got that problem that you could go use that integer as if it was the success. There's no way to know. Java's not keeping track of whether you found the right thing or not. When it gives you back this n, you have to check if that n is success or failure. Okay. Now, this is doing things with integers. Now, over here, I did it in a more modern way. Here, the stream class can also search a string, a list. Okay. And then here, what I'm going to do is I'm going to filter the list on the cats, and then it's going to say whether it found any cats in the list. And if it didn't find any cats, it returns null. Now here, this is where things get real interesting. Null here acts like -1 did here. This thing is returning an OR. I found what you're looking for, or I couldn't find what you're looking for. If it finds what you're looking for, it gives you a reference to the thing it found. If it couldn't find what you're looking for, it returns a null. But that's you're still back to this problem that you still have this variable S1, and it's either null or not null. Notice there's the word all or there. It's either null or not null, but the compiler doesn't know. The compiler has no way of knowing what was the result of this thing. Okay. So if you got back null and then you try to use it, so for example, if I do here s1.length, well, I've got a problem now. That might crash my program. That might crash my program. And if we try it here, oh, wait a minute. Yeah. Okay. Notice that n is -1. That was the failure. I'm stepping through the list looking for something. Okay. My program crashed. See? Now, the compiler didn't know that I need to say if S1 not equal to null, then do that. But I have to remember to say, well, this thing's an OR. it's either success or failure. The compiler isn't helping me remember that I have to check for success or failure. It's up to me to check this. Okay. Now, here's an interesting point of view of this. Let me show you another, okay. This is what we're talking about now is really what's really going on in modern programming. This is a huge problem. What we're talking about here is really, really, really a big problem that is being trying to solve by programs. Now, let me show you another example of this. Suppose I have a string variable s1, okay? And I can set it equal to null, okay? Then let me do another thing. Let me have an int n equal to null dot length. Okay. There is no length method in null. Okay, so I get a compiler error. Now, here's something that's real fundamental that very few people realize. Null is a value of type null type. It has a type. The type of null is null type. Okay, but that's actually really wrong. See, look at this. I mean, think about this. Int x equal 2.3. Will that compile? Is that going to compile? Int x equals 2.3. Can you put a double inside of an integer? The answer is no. Okay. That won't compile. See, none of those are compile. You can't put that type value in that type variable. You can't put that type value in that type variable. You can't put that type value in that type variable. The type of the value has to be the same as the type of the variable. Okay, this is a fundamental fact of programming, except it's not true. Okay, now all of these fail because the type of the value is not the same as the type of the variable. The type of the value is not the same as the type of the variable. The type of the value is not the same as the type of the variable. Everywhere in Java, the type of the value has to agree with the type of the variable, except for one place. Null. That's the only exception. And almost nobody realizes that this is a bizarre exception in the language, and it's actually a huge mistake. And I'll show you in a second why. The type here of the value is null type. The type of the variable is string. You should not be able to put null in there, but you can. And this is called the billion-dollar mistake. Okay. Null is the misguided invention of the British computer scientist Tony Hoare. Tony Hoare is one of the persons who invented modern programming languages. He was given the equivalent of a Nobel Prize for his work. In the 60s, when he was inventing a language called ALGOL, he gave the language this idea of a null, meaning something that doesn't point to anything. And he essentially made it so that you could do this. And then many years later, he realized that was a huge mistake. This was a huge mistake. And he calls it the billion-dollar mistake because of all the money that's been spent over the years tracking down errors in programs because of null pointer errors. Okay. And if you go through here, you'll see lots of people have written about this. Yeah, null pointer references, the $1 billion mistake. You know, here's the you click here. Here's the biography of Tony Hoare. And it was in 2009 when he gave a speech, and he pointed out how null references was a big mistake. You know, eventually they realized, it took them a long time to realize that it was a really bad decision. The heart of the problem is or. What we're doing here is we're saying that S1 is either a string or it's null. There's really an implicit or here. S1 is a string or it's a null. Okay, so everywhere you have a string reference variable, you really have an or. It's either a string or it's null type. But that means you can never rely on this thing being really a string. So every time you want to use this reference variable, and if you look at professionally written programs, you'll see that they are constantly having to check, is this thing a null? Is this thing a null? Is this thing a null? Because if you dereference a null, your program crashes. Now, look it down here. I'll do int m equals s.length. The compiler caught this one. The compiler will not catch this one. Now, okay, I'll comment out this one because the compiler, it's all in error. Look, S1 is null. So this is not valid. But the compiler does not keep track of the value of S. S has type string. String has a length method if it's really a string. But we just said it's really an or. It could be a string or a null, but the compiler is not keeping track of the null here. If you call length directly on null, the compiler is smart enough to figure that out. But now, oh, I have to get rid of all these. See, none of these will compile either. Okay. What did I do wrong here? Oh, S1. I called it S1. Okay. See, compiler didn't know, and my program crashes because the compiler says S1 is a string. String has length. What the compiler doesn't say is S1 is a string or it's null. So this may not run properly. And that's a huge mistake. Okay. Reference variables are actually ors. They are a pointer to the real thing or they're null. And null is a different type. You know, we saw a minute ago, null is actually literally a different type. Null is not a string. So if we go back over, go back to here, you can see it clearly in the error message. Null type cannot be dereferenced. Okay, the null value, this is the null value. The null value is a value of type null type. The null type only has one value, null. Every reference variable is allowed to have the null type value, but that means that every reference variable is really an or. It's an or of, in this case, an or of string and null. Okay. And that means that everywhere where the compiler says this is okay, it really may not be okay because of the other type that could be there. But the compiler doesn't keep track of them. Okay, now go back to this searching example. Well, actually, no, let's look at another ML example where I'll show you how ML tries to deal with something like this. Okay. ML has a more rigorous way of ML makes explicit the idea that you have an or. Java's doing it without being explicit, and it's just a mistake. I mean, it's well known by this point that if the Java language was being invented today, they would not. Oh, for example, the Rust programming language has no nulls in it. People who invent languages nowadays do not give the languages nulls. So, for example, if you Google Rust null, you'll see that you'll get, well, Rust can never be null. there is something, there is a null in Rust, but it's kind of weird. It's not like, you can't just assign it. There's a thing called null, but you can't assign it to pointers. Okay. Rust has no null type. The inventor of, here you get back to this inventor of null, is call it the $1 billion mistake. The Rust language was designed not to use nulls. Okay. So modern programming languages, there's some other languages that have been invented recently that also don't have nulls in them. Java, C++, and C have null in them, but it's because they're older. Modern languages don't, like ML doesn't have a null, and Haskell doesn't have null, and Rust doesn't have null. Okay, they have OR instead. They explicitly have this OR type. So here's an ML program. Okay, I'm going to use the OR here to create a new type called int OR, int error. What this is saying that this is a type that holds either an int or it holds an error part. So it's got an int part and an error part. And this is going to be a way of saying, like, this would be the search thing. The index of method should return something like this: an integer meaning success, and not -1 to mean failure, something that says the error part. So now I can use this now to do something that would explicitly say, I found what you're looking for, or I didn't find what you're looking for. So I'm going to use it or to explicitly say found or not found. Okay. Now here I'm going to write a function that's going to take a list and an item. And this is the member, it's essentially the member function. It's going to ask, is this item in the list? Okay. But it's going to return the error part when it couldn't find the item. Okay. So if you give me an empty list, I'm not going to find anything in it. So I'm going to return the error part. Okay. Otherwise, I go through here and do the other part. Now, if I do find what you're looking for, I'm going to return the index of where it is. So I return an int part. Okay. So on success, I give you an integer, but it's denoted as the integer part of an int error. And if I can't find what I want, what you're looking for, I give you back an error part, which is the error part of an int error. Okay. Right. Now, what happens is, if I search a list, this is what I would do in Java. There would be a mistake. If you search a list, you get back an integer. So then you could use that integer to search another list. Okay. So here I would say, in this list, find where 5 is. Then use that index to find where the equivalent thing is in this list. So for example, if 5 was right, like, see, 5 is right there. So that's index 1. So this returns index 1. So then index 1 here would be the 2. So I'd be finding the thing in this list that's in the same place as where the 5 is in this list. Now, if I ask for a 0 here, that's where things would go wrong. Because if you ask for a 0 here, it's not in this list. Java would give you back -1. If you ask for the -1 index in here, your program crashes. Now, ML won't even compile this. This guy won't compile an ML. This thing will not compile an ML. ML won't let you do what Java does. Because what ML is going to do is going to say that this thing returns an int error. An int error is not an integer. It's an integer or an error. So this thing is not a valid integer. So ML won't let you use it as if it was an integer. Instead, in ML, you got to do this. You got to say, find 5, get back the int error. Pattern match the return value. If the return value has the pattern of the int part, I can go ahead and use it. On the other hand, if the pattern comes back with the error part, I'm not handling the error. Now notice I'm actually not doing the right thing here. I'm not handling the error, but I am at least skipping the error. If this thing comes back as I couldn't find the 5, I don't this thing won't pattern match. See, this thing won't pattern match in that case. Okay. Now let's go ahead and enter this into ML and see what happens. I'll open a command prompt here and run ML from the command prompt. Okay, so SML, and I'll tell it to load the file search list. Okay. And let's look at what ML did. Okay. Okay. It defined the data type. That was okay. Then it defined the function find in. It auto-loaded. I used something in one of the libraries. So it auto-loaded, forget which one it auto-loaded this nth, auto-loaded this thing. This is a function that finds the nth thing in a list. Okay, so that's part of the list library. Okay, so then this one here, this one crashed. See, this one didn't compile. Okay, that one's wrong. I can't ask, the ML says this thing returns an int error, not an int, so I can't use it in this function. So I have to comment out that because that one correctly doesn't compile. That's a wrong thing to be doing. It's not a good idea to be using this as if it was an int, which is what Java lets you do. Java lets you use, this is the equivalent of index of. I should actually call it index of. Because it's exactly what it is. I called it find in, but it's returning the index. So I actually should have called this, you can just change the name. It is index of. Okay, so it's the index of x in x's. Okay, so it's just like Java. You know, if you ask for the index of something, well, Java will give you -1 when it couldn't find it. This one will give you an error part of an int error. It explicitly says success or failure. Okay, so then this thing won't compile because this thing is using an int error as if it was an int, which is what Java does. It uses an int as if it's really an int error, but it's using it as an int. Okay, so this thing doesn't work right. Okay, now let's see what happens when you get down to here. So reload it. Okay. Oh, I have to change the name. Index of. Okay. Now, in a sense, this is no longer really a good name for this thing because it doesn't always give you back an index. You know, index of gives you back an index if it did find it, and it gives you back an error if it didn't find it. So in a way, index of is, but that's the same thing with true Java. The index of doesn't always give you back an index. It gives you back an index if it found it, and it gives you back -1, which is not an index if it didn't find it. Okay. Well, okay. Now, here's where things get interesting. This compiled, but the compiler gave me a warning. The compilers essentially didn't, the compiler noticed that I didn't handle the other pattern here. There's two patterns to an int error. There's the int part pattern and the error part pattern. So this type has two patterns. I only dealt with one of the patterns. Okay. And so the compiler tells me, warning, binding not exhaustive. You only checked one of the two patterns. Now that's a good warning because I'm not checking for the error condition. Now in Java, the compiler wouldn't even know that there was an issue here. When we did this with the Java examples, when you call index of, you get back an answer, and the compiler thinks it's an int and thinks you can do anything you want with that int. The compiler doesn't realize that there's really something deeper going on here. Index of is giving you two answers, success or failure. ML noticed that, okay? ML noticed that. Now, suppose I look for something that isn't in the list. Then this is going to give me back the error part, and this thing will crash because that won't pattern match. But I was warned here that I did something wrong. Yeah. So here it's like here I'm pretending like it's Java. I'm pretending that I'm always going to get success, and I use it as if I'm always going to get success, which is what happens in Java. Yeah. I didn't do the two patterns, but the thing is, ML at least warns me here. Yeah. In the case of the success, it warns me, but you didn't check for the error condition here. So you get these warnings. In ML's an older language. Most of the modern languages are carrying this one step farther. If a data type has two patterns and you only check one of the patterns, instead of giving you a warning, you get a compiler error. The modern languages say that it's not a good idea to let you skip patterns. So they will now force you to check all the patterns, okay? So I should be checking all the patterns. I should have a pattern match here, something that says, if I have this pattern, do this. If I have the other pattern, the error case, well, then I have to do something about the error. I have to do something about the error. But that same thing in true in Java. If in these examples I did in Java, I just wrote, oh, if the index is not valid, don't use it. Okay, so I just skipped using it. So I can do that over here too. One possibility is if I get back that pattern, I just don't do anything. Okay, just skip over it. But at least I would have to, I would have to check it. Here I'm not forced to make the check. I'm not forced to make the check. The compiler doesn't warn me, it doesn't force me. Okay, so over here, if I remember to make the check, I make the check, and then I can avoid crashing when this thing is not a valid index. Okay. Now, if we go back to the example where, oh no, it was over here. With string, this one was using null instead of -1. Okay. Okay. When I use the stream class, here I'm using the list class. Here I'm converting the list to a stream. That's the more modern way. This is entering Java's functional programming world. If you remember when I showed you those problems on Coding Bat that did functional Java, they used streams, not lists. So here I convert the list to a stream, and then you use filter method, filter, and there's a lambda expression. There's a higher order. There's a anonymous function. And I'm filtering the stream with this anonymous function. Then I'm saying, is there anything in this stream? This stream could end up being empty because in this case, if you don't find cats, this stream is empty. So then find anything returns false. So then, or else you return null. But notice I'm using null to mean failure. And then this thing could hold a null, which is a failure. Okay. Turns out that this thing does not, here's what's really being returned by here. So Java has something called an optional. Optional is Java's way of trying to do an OR type. When you say optional string, you're saying this object holds a string or it holds nothing. See, it's optional that the string is really there. When you call this filter method, so you take this list, convert it to a stream, filter the stream looking for cats. If you don't find any cats, you call find first. find first will give you the first thing in this thing gives you back the list of cats it found. And then this gives you back a pointer to the first one, or it gives you back an empty optional. Okay. So here Java is trying to do an OR. This optional is equivalent to what we did over here with the int error. It's a fake OR type. Java doesn't have OR types. This optional is Java's attempt at having an OR type. An optional holds a string or it doesn't hold anything. So if we go over here and Google Java optional, well, Java 11, this is where Java is trying to mimic ML and other programming languages. See, a container which may or may not contain non-null values. Okay, so there's the OR. Okay, now the trouble is it's not really an OR type. The Java implementation of optional is well known to be broken. It's better than nothing, but it's not an OR type. And if you Google you'll find lots of people talking about what's wrong with the Java optional class. You know, there's really lots of, how to use Java optional correctly, understanding, accepting, leveraging optional in Java. There's actually, the optional class is not quite right, okay? And, there's actually a lot of people who've written articles to the effect of there's something wrong with Java's optional. It's not really an OR type. It's close to being an OR type, but it's not quite an OR type. But over here, we use it as an OR type. Let's see, where'd it go? Okay. Now, what happens is you get back this optional, okay? The optional is actually storing either what you want. Now here, what I did is I say, take the optional and call the or else. The or else checks if the optional is holding a string or not. And if it's holding a string, this thing will be the string. Otherwise, it's going to hold none. So now my S2 will always hold a valid string. My S2 is not going to ever be null. I'm going to either hold the string I found or I'm going to hold none. Okay. If I run this and go to the end, you'll see that S2 holds none because I didn't find the string in there. Okay. And if I search for dog, now dog will be successful. So the optional will hold dog. Now the optional is going to hold dog because this thing will, oh, I should change this one to dog also. This one will find dog. Okay. See, S2 is pointing to dog now. Okay. So it found the dog in the string. Okay. And we'll see, why is n -1? Oh, I didn't change this one. I didn't change this one. This one's still looking for cats. So this one's looking for cats. This one's looking for dogs. Okay, so this one found the dog, but it found the dog using, here the string could be null. If it didn't find the dog, this one, remember, if I put dogs here and dogs here, then this one, S1 will be a null, which is a problem. Whereas this one, S2 won't be null. It'll always be a string, but it'll be the string none if I didn't find dogs. Okay. S1 is null. That's not good. See, S1 is a null reference. I have to be careful about S1. Okay. S2 is none. So I gave it a value that's, none is better than null because it really is a string, but it's still a failure. I still have to know that this thing's a failure. but I have a better way. Java now will let me test if it's a failure in a better way. I have a more, it's still not as good as ML is, because it's not a true OR type. It's kind of a fake OR type. So it doesn't protect you as well as ML does. Okay. But the key idea here is that the null value is used in Java as an OR. Okay. It's being, left and right, we're saying, I found what you're looking for, or I didn't find what you're looking for. But if I didn't find what you're looking for, I'm going to give you back a null. And null means I didn't find it. Now, null could just mean I screwed up. And there's lots of reasons why a value can be null. It could also be null because you just goofed up. You forgot to initialize a variable, for example. One common way to get a null value is if you do okay. Well, actually, that won't give it no, that doesn't give S3 a null. If you do that, S3 is uninitialized. So if uninitialized is not the same thing as null. So if you have a local variable, the way I would get a null is to create a it's got to be either an instance variable or a static variable. See, it's null. That's a real common way to get nulls. Local variables won't do that. Okay, if I create let me put it at the top. This one's a little bit interesting. This and this don't mean the same thing. Okay. Notice what the visualizer did. S3 is null. S4 is nowhere in sight. Skipped over it because there is no S4 yet. This is an uninitialized variable, an uninitialized local variable. This is an uninitialized static variable. Uninitialized static variables are initialized automatically to null. Uninitialized local variables don't exist until you initialize them. So if I do the following, I'll get a compiler error. S4 may not be initialized. It doesn't exist yet. Local variables don't exist. Now, if I try to do S3, that's fine. Notice that S3 never got initialized, but I can print it. It'll print as null. Okay. See, static variables exist automatically whether you initialize them or not. If you don't initialize them, they get a default value, and reference variables default to null. That's how people accidentally get null values in their programs. Okay, in a sense, that's an accidental null. Local variables, Java treats them differently. If you don't initialize a local variable, it doesn't exist yet. And you can't accidentally use an uninitialized local variable, but you can accidentally use an uninitialized static or instance variable. Down here, we're using null to mean something different. Here, null does not mean I forgot to initialize the variable. Null means I didn't find what you're looking for. That's a hugely different thing. Okay. That's not, see here, null means I couldn't find something. Here, null means, oops, I forgot to initialize something. This is a mistake. This is a programming mistake on my part. This is a design mistake on the part of Java, but it's not a programming error. Here, null is used to mean I couldn't find what you're looking for. And I have to be careful to use the null properly. But so now null's got three completely different uses. Okay, null is a default value for uninitialized static variables. Null is a flag to mean I couldn't find what you're looking for. And null is the null type, meaning, well, it doesn't really have a meaning. Null is just a null type. So null's got this concept of being the null type. And then it could be a value that's there by accident, essentially. And it could be a value that's there to mean something, meaning I couldn't find what you're looking for. This really screws up programming. It's well known that this is a source of massive numbers of costly bugs. That's why it's referred to as the billion-dollar error. It is what causes programming errors. It's one of the main sources of errors in programs. The people who invented ML thought about it completely differently. They saw that there's an or here. They saw that, you're saying I found it or I didn't find it. Just like over here, which may or, see the key is or. Or, it's an or. There's a value in the optional or there isn't anything in the optional. Where the isn't anything means that's the case where you were looking for something, you couldn't find it. So then you would have the empty case of an optional. Okay, so you can ask if an optional is empty or not. See, there's a method here to find out, ask, is this optional empty or not? Okay. I'm looking for the constructor. Yeah, or optional is kind of weird. Notice that there's no constructor for optional. Optional doesn't have a constructor. Optional is built by factory methods. So you get optionals in where you don't have a constructor for optional. It's a weird kind of it's a weird class. It was added to Java fairly recently. See, it was added to Java in Java 1.8, which is not that long ago. Okay, so it's a fairly recent addition to Java. It didn't exist for the first 15 or 20 years that Java existed. There was no optional. It was added to Java when people started thinking that Java needed to learn from the functional programming languages. So the optional was like ML has an optional. Haskell has optional. Okay. Well, actually, Haskell's got a funny name for it. It's called the maybe. Why would it call it maybe? Java called it optional. Haskell calls it maybe. It's right there. Called it maybe because the value may not be there. Maybe there's a value there. Java thinks it is optional. There's a value there or there's not a value there. Haskell thinks of it as maybe there's a value or maybe not there's a value. So they called it the maybe. So it has two sides to it. One side holds something. That's our one side holds something and the other side doesn't hold anything. It denotes the empty part. I called it the error part here. They actually call it the empty part. In both in Java optional and in the Haskell maybe, the other part is called the empty part, not the error part. But it's all the empty part is always used to denote error. It's used to denote that something didn't find an answer. So the maybe type in Haskell is used to see. In general, this is referred to as option types. And see, all these languages have option types. Rust, Swift, Haskell, F#, Camel, and they didn't put Java in this list because Java's option type is kind of flaky. But it's a type that says, well, maybe there's a value in here or maybe there isn't a value here. Okay, so it's called an option type or a maybe type. This is one of the modern inventions of modern programming languages. And they didn't mention ML in here, but F# is a dialect of ML. So I think F#, well, Camel and F# are two more modern versions of ML. So I think they didn't put ML in this list because they put both OCaml and F# in there. Okay. In OCaml, for example, the two parts are called sum X and none. Okay. So they're called, this would be sum and this would be none. Okay. In F#, they're called also sum and none. Okay. In Haskell, the two parts have kind of funny names. Let me see if the two parts are called just and nothing. So in Haskell, you'd have just int or nothing. And I think just is a really bad name for this part. It doesn't really read right. So it's just int or nothing. Okay. In the other languages, it's some int or nothing. In Haskell, it's just int or nothing. And yeah, so there's the two parts. In general, these are referred to as option types. And they're used now in modern programming. Whenever you search for something, you always return an option type. Okay. Whenever in a modern language you search for something, you return option. Now, if you go to Java, one more look up Java stream. Go to the stream class. In the stream class, when you look for something in a stream, you get back an optional. See, they don't give you, there's no index of in streams. They don't do it that way anymore. Now they do it. Now streams are also from Java 8. See, they were more recent. They started doing things differently. If they were rewriting Java from scratch, index of would return an optional. It wouldn't return an int, it would return an optional of int. Okay, so it would say, I'm returning you a number, or I'm returning to you nothing, because I couldn't find what you're looking for. So all the methods in the modern stream class that search for something return an optional. When they can't find, when they don't find what they're looking for, they return an empty optional. Okay, so that's the modern way to do things. Except that, again, Java's optional is a little bit flaky. It doesn't work as well as it should. It doesn't work as well as it really should, but, and C++ has done this too. C++, I don't remember what they call it. I can't remember if C++ calls it, yeah, I guess so, STD optional. See, there's the or, that may or may not be present. See? Okay. A common use case is for return values of function that may fail. See, that's the case. If a function may fail, instead of returning nulls, which is really bad, modern programming returns optionals, which are this algebraic data type. It's a success or a failure. Now, I think C++'s optional is a lot like Java's. It's kind of a fake optional. It's not, notice it wasn't in the list of optional types in Wikipedia, because I think it, like Java, it's kind of not really, doesn't work quite the way it should. It doesn't work as well as optional works in true functional programming languages. But see, everybody's adopting the ideas of modern functional languages. Optionals were in ML going back 30 years. Optionals were added to C++ in 2011. I'm pretty sure this was added into, I don't know if it says in here, but I can't remember if this thing tells you when things were added to the language. It probably does. I think it was added in C++ 11, unless it was added after that even. Maybe it wasn't even until maybe it wasn't until C++, because here I keep saying C++ 17. So maybe it was even more recently than C++ 11. C++ 11 came out about the same time that Java 8 did. That was when both languages made a big jump towards being more like learning from functional languages. So C++ 11 and Java 8 were the versions of C++ and Java that made the big leap forward. Now, I thought optional was in C++ 11, but maybe it wasn't. Yeah, it might not have been until C++ 17, which is even more recently, because most of this stuff seems to be referencing C++ 17. These languages are trying to modernize themselves. And where are they getting their ideas from? Mostly ML and Haskell, the two most famous functional programming languages. Yeah, so ML is an older of the two. ML is the older language of the two. ML dates from the 80s and Haskell dates from the 90s. Okay, so these languages are trying really hard to develop these ideas. Okay, now let's see. Oh, okay, we went over. I didn't pay attention to time. Okay, so the point of this is to try to make you realize that these abstract ideas that these functional programming languages invented are being taken seriously by everybody now. They lingered in the world of functional programming for a long time and didn't get taken seriously. And then about 10 years ago, the world of C++ and Java started realizing that they were really making a mistake by ignoring these ideas. And things like algebraic data types are now becoming more, they're in every new language. Everybody who invents a language now gives the language algebraic data types. They have optional, which is an example of an algebraic data type, and they use these things. They use these modern functional programming ideas in the languages. And Java and C++ are trying their best to mimic these ideas, and with some success and some failure. Like the optional in Java is considered a bit of it's better than what was there before, but it's not considered all that great either. Okay, so let's quit there because we went over. But if you're interested in modern programming, this is what you need to learn. If you want to learn modern programming languages, you'll learning ML, learning Haskell, learning F#, learning these languages is good because you'll find out what Java is trying to do. You'll have a sense of what it is Java is trying to do when you learn those languages. Okay, so we'll quit there. And this is the last day we meet. So next week we don't have class. I'll be here all day Tuesday when you have the exam. I'll be in office hour I'll have an office hour on Tuesday. So my office hours at 3:30 on Tuesday, Thursday. So I'll be there in office hours. So if you want to meet with me in Zoom, but anytime during the day, if you send me an email, I'll try to answer. So that day, I'll try to answer the emails as quickly as possible. So if you're doing the test and you want to ask a question about a problem in the test, I'll try to answer those as quickly as possible. So we won't have class on Tuesday or Thursday, but I'll be there in office hours. And I'm sorry this was such a weird, this is not the greatest way in the world to take a class. I hope next year, we'll be back to normal. I mean, with any luck, everything will be normal next year, and we'll be in a classroom and we can see each other. And hopefully that'll be better than this is. Okay, so, but if you have questions about anything that's left over from the class, please send me email or send any, anybody got any questions before we quit? At the last second here. Anybody have a last second question? Oh, and one last thing. If you look up algebraic data types, right away they talk about pattern matching. They go hand in hand. This is the real modern, algebraic data types and pattern matching. The two brilliant ideas in functional in ML. They go hand in hand, and that's once you get the hang of this kind of programming, it's really elegant. 10 years from now, we'll be teaching programming differently than we do now because this will become ubiquitous. We'll be teaching algebraic data types and pattern matching as just that'll be the way people do programming in another 10 or 15 years. Maybe not take that long. I think it's going to take 10 or 15 years, but eventually, which is well within your career, this will be the standard way to program. Algebraic data types and pattern matching. That's going to be what everyone's going to be doing. Okay, so good time to learn it is now. Okay, I will quit there. And so good luck with the rest of your, with your final exams. Good luck with the rest of the semester and have a good summer. Okay, bye.